Okay, hi, my name is Rebecca. I use she, they pronouns, and I am really excited to be here and also a little bit nervous. Okay, so I'm going to be presenting some of my recent work on non-binary gender expression and online interactions. And really quickly, I want to say for the purposes of this project, when we say non-binary, we mean someone who identifies not strictly as a man or strictly as a woman, okay? So that can encompass a lot of different things. So that's how we're operationalizing it here. For a little bit of background, first of all, we've seen a pretty big increase in people publicly identifying as non-binary recently. Last year, Pew Research Center said that 1.6% of US adults identify as genderqueer, and that jumps to 5% for young adults, which is pretty substantial. Second of all, we've seen documentation of people living outside of the gender binary for a very long time, right? We've seen, as mentioned earlier, we've seen Two-Spirit people from Native America, the Feminielli from Neapolitan culture, and yet computational models still don't take non-binary people into account. We typically see gender codified as either being a man or a woman. Sometimes we'll see an unknown category. That's like about the extent of it. And this is particularly an issue because we know that exclusion from training data means that we don't know what will happen to the non-binary population when these computational systems are deployed, right? We don't know how they're going to be flagged and whether they're going to be flagged in inappropriate ways that are dangerous. So what we do in this project is we see if there's a difference in social media behavior for non-binary people versus binary people, and we'll explain how we figure that out. Because if so, that's an indication that a failure to take non-binary users into account could result in biased computational models being deployed. Okay, so what we did is we started with a database from Julie Jiang et al., USC's own, where they took a COVID-19 Twitter database and they extracted the pronouns from users from their Twitter biographies using regex expressions, which is really cool because we really rarely see gender data as self-identified. So that's pretty neat in my opinion. And the pronoun groups that they considered were any permutations of she, her, hers, he, him, his, he, his, whatever, they, them, theirs, Z-them, and Z-them. And those are two Z-thems with XE and ZE. So that means we considered, you know, she, they, Z, right? He, she, all those different permutations. And then we noted the pronoun groups with at least 100 unique users in that data set. And then we noted for each, then we sampled 100 users for each of those substantially large non-binary pronoun groups and sampled 1,000 tweets. And the 1,000 tweets that we took were before September 29, 2022, which is before the Twitter change in leadership. So just wanted to note that. We also collected replies, but I'm not going to talk about that because we don't have time. So I wanted to talk. We've done a lot on this project so far, but I'm just going to talk about two particular results that I think are interesting. So first of all, for activity analysis, we looked at how do these users interact with Twitter? How do they interact with other people? What are they putting out, right? And we decided to come up with this metric, which is statuses to favorites. So the number of tweets you're putting out over the number of tweets you're liking. So the indication is that if you're liking a lot of tweets, but not really tweeting, then you're like lurking most of the time when you're on social media, right? Versus if you're not liking that much and you have a lot of tweets, you're kind of being more vocal, right? And you're like constantly tweeting. So 1.0 is an equal ratio of tweeting to liking. And I know it's a down arrow, but it says increasing, just stay with me. So it's ordered in the popularity of those pronoun groups in the original COVID data set that we used, okay? So what we end up seeing here is that as you go up, as the pronoun groups are less common, you kind of get louder, more vocal Twitter users, which is interesting. To me, at least. Okay, and then we're looking at attention, which is how do people like and tweet, like how do you receive attention on social media, right? And basically, I'll just tell you really quickly what we found, which is that users with more popular pronouns tend to get more retweets and likes, and users with less popular pronouns tend to get more replies, which is kind of interesting. And if you remember from the previous slide, users with less popular pronouns are additionally more vocal. So we have users with less popular pronouns being part of kind of active Twitter communities, right? Where people are tweeting a lot and replying a lot, versus users with more popular pronouns getting more attention on Twitter, but being a bit more quiet. And something that I think is really interesting is Twitter recently posted on GitHub their like recommendation algorithm, according to them. We don't know what's true and what's not, but looking at it, the weights for who gets like more weights on the Twitter timeline, right? Who gets boosted on the Twitter timeline more is if you get a lot of likes, if you get a lot of retweets, and that has higher weights versus if you get replies, it's not very weighted. So that's kind of interesting how the results fall in there. So yeah, between these three things, we notice that there is indeed a difference between how non-binary users and binary users, according to self-identified pronoun series, are on Twitter. And that's a really big deal, because if there are in fact these differences, if machine learning models do not, if we continue to impose this like rigid male-female dichotomy, we're going to be missing a lot, and we're raising a very high risk for this population in terms of bias. So yeah, thank you so much for my lightning talk.